Hi, welcome to you 2.2 for physical science on net force. This is going to be a little bit longer video, um, so hold on. All right, first we need to establish some things, and you're going to need to write these in your notes. 1. Net force is the total of all the forces. 2. If the net force is 0, the object is either standing still or moving at a constant speed. 3. If the net force is not 0, the object will accelerate. 4. Forces that go in the same direction will add, while forces in opposite directions will subtract. So let's look at part 1. Part 1 is connecting force diagrams and calculating force. So here's the question. Draw a force diagram for the cat sitting on the mat. Part 2 is if the cat has a mass of 17 kilograms, what is the force of gravity on the cat? And then finally, what is the force of normal on the cat? So the force diagram would look like this. We have a downward arrow for the force of gravity on the cat by the earth, and an upward arrow for the force of normal on the cat by the mat, because the mat's holding up the cat. With that as the force diagram, we can calculate the force. Force is equal to mass times acceleration. So the Fg is the mass, 17, times the acceleration due to gravity, which is 9.8, to get the force of gravity, the downward force of gravity, to be 166.6 newtons. Now, if the downward force is 166.6 newtons, the upward force has to equal the same thing. The cat's not moving. So therefore, the net force, total up and down, is 0 because they're in opposite directions. Okay. Part 2. What happens if you have more than one object? Again, we're going to draw a force diagram. We're going to find the force of gravity, and then we're going to find those forces of tension. And we're going to go based on this swing having 2 ropes holding it up. So here's your force diagram, right? The force diagram for the swing is a downward arrow for the force of gravity on the swing by the earth. And then you have 2 ropes, either side. You have the force of tension on the swing by rope 1 and the force of tension on the swing by rope 2. And no matter what we put on the swing, that force diagram doesn't change. It's still on the swing. So, playing pretend, if the swing has a mass of 20 and Joey, little boy, is 48 kilograms, sits on the swing, and holds his dog that is 12 kilograms, what is the force of gravity? Well, Fg is still equal to mass times acceleration, but now we need the total mass, so you just add them all up. 20, 48, and 12 is equal to 80, so the force of gravity is 80 times 9.8, which is 784 newtons. Therefore, what is the force of tension in each rope? Well, since there are 2 ropes holding it up, the force of tension is equal to the force of gravity divided by the number of holds. You might want to add that to a formula sheet. If you had to find the force of tension, it is equal to the force of gravity divided by the number of holds. So that means that each force of tension is 392 newtons. Okay. Part 3. So how do we find that net force again? Well, to find the net force, you either add or subtract the given forces. In the picture on the left, the blue is pulling to the left with 150 newtons, while the red is pulling to the right with 100 newtons. That's going to give a net force of 200 newtons to the left. Direction is important here. The picture on the right shows two people pulling together in a leftward force of 200 newtons. So since they're going together, right, you add them together and the total is 200 newtons. Now in this one, notice that again, you add if they're going the same direction, you subtract if they're going different directions. And this time they're actually equal. Even though they're different sizes of people, they're still equal on both sides. Both sides are pulling with 200 newtons. Therefore, the sum of forces is 0. So, what happens to an object if the net force is not 0? To find the net force, remember that you add the given forces. So what is going to happen in this situation? Let's go see. You can see that I've added the speedometer, right? What do you think is going to happen? If I push go, well, let's see. Nothing happens. Because remember, the net force is 0. Since the net force is 0, it's either not moving or it's going to move at a constant speed. Okay? What about what happens? What's going to happen now? We can even take that big guy off. What's going to happen now? If I have a left force of 50 and a right force of 100, and the total of the forces is 50 to the right, what's going to happen to my speed? Watch the speedometer real careful. Ready? Go. What happened? Well, it sped up. It increased in speed because the net force was not 0. Therefore, it had some acceleration. That I added to Canvas at the bottom, it says Force and Motion Basics. And I want to walk you through all 3 of the other situations. So right now, we have a crate sitting on a skateboard on a very flat surface. And it's not moving. So the force diagram for this would be force of gravity going down, force of normal going up, and that would be a net force of 0 because it's not moving. But as soon as I apply any force to it, and the more force, the faster it goes. Watch that speedometer. Okay? The more force I apply, the faster it goes. Now, if I add more weight to it, right? More mass, but keep the same amount of force, is it going to speed up as fast? Is it going to slow down? Or is it going to go at a constant speed? Let's find out. Looks to me like it's still going, but just not as fast as it was before. Okay. So what happens if I now apply a force in the opposite direction? What's going to happen to my speed then? Notice I was already going fast, and if I apply a force in the opposite direction, I can eventually slow down to a stop and speed up in the other direction. And you see this in everyday life. You want to slow something down or you're catching something, and you've got to slow it down so that you can turn it and speed it back up. Now let's look at friction. So same situation, but now you're on carpet. So if we turn this up and there's a lot of friction, okay, and we start with the same crate and we apply 50 newtons of force, what I want you to notice is that you have 50 newtons of friction at the same time and we're not moving. So I have to push harder to overcome the friction. And I finally get to 300 newtons in order to overcome the friction. Okay, so notice the total of the forces was 112 newtons. Or the little man, applied 300 newtons. Friction applied 188 newtons. Now I can lower the amount of friction and notice what it does. It changes the sum of that force. And if I change the sum of the force, I can actually make it go faster. The last simulation on here is acceleration. And I'm going to turn everything on again so that you can see the acceleration and the speed. So this one is actually calculating everything for you, essentially. You still have the force of gravity and the force of normal, but those are going to cancel each other out. So if I have this 50 Newton crate and I have a little bit of friction, if I apply a force to it, nothing moves, nothing moves, still nothing. And now notice what is happening. I have a constant acceleration and my speed is increasing by 1.52 meters per second every second. And I have applied a 200 Newton force. I have a 50 kilogram object and 76 newtons as a total force because my force of friction is 124. So what I want you to realize is that in order to calculate this acceleration of 1.52, I would take the total force, 76, and divide by 50, divided by the mass, and that will give me my acceleration. Okay? So, you're going to have some problems similar to this in class. Thanks for watching.